Hello, this is Mr. Stansbury. I'm going to take you through the 19K notes on optimization. Okay, at the end of this, you should be able to say that I can find the optimal value for a variable in various real-life situations. Okay, so first thing, example 18 from page 632. Two numbers have a sum of 10. What is the maximum value of their product? All right, so let's let one number equal x, and then so the other number will have to be, let's see, it's a total sum of 10, so you got to take 10 and subtract x to get what the other number is. So one number is x and the other one is 10 minus x. Okay, so the product is simply going to be x times 10 minus x, right? So distribute that through and we get 10x minus x squared, right? And again, if we're trying to find the maximum or the minimum value of a product, then we know that the slope of the line tangent to that is going to have to be 0, because it's either going to be, let's see, in this case it's negative x squared, so our graph's going to look something like this. What we're looking for is this point, and we know that the tangent at that point there, the slope is going to equal 0. Okay, so let's find the derivative. So that is, let's see, 10, right? And then that goes away. 2 times negative x is negative 2x. So we just get 10 minus 2x. And again, we know that this slope over here has to be, the tangent slope has to be 0. So 0 equals, let's see, we can factor a 2 out of both of these. And we're left with 5 minus x. Okay, so in this case here, x is going to, only way that to make this equal to 0 is if x equals 5. Okay, so we know that the one number is 5. So to find the other number, it's going to be 10 minus x, which in this case is 5, which gives us 5. So our two numbers are 5 and 5. So 5 times 5 is 25. So the maximum value of the product is going to have to be 25. And again, I know that there's easier ways to do that, but this really kind of helps us. Hopefully it's a nice simple way of showing how finding the derivative of something is going to help us find either our minimum or maximum values, because again, that's when the tangent, the slope of the tangent is 0. One last example to hit, and this is example 20 from page 634. Okay, square corners are cut from a piece of 12 centimeter by 12 centimeter tin, which is then bent in the form of a box. What size squares should be removed if the volume is to be maximized? Okay, so first off, let's draw ourselves a pretty picture here. So here is a square piece of tin, 12 centimeters by 12 centimeters, and what you're going to do is you're going to cut little squares out of square corners out of each one of those to try to let's see, we're trying to maximize the volume. Okay, so the way I'm going to look at this here is, okay, once we cut these squares, then we have these orange dotted lines are going to be what is the base of the box when these sides get folded up. Okay, so if this whole thing here is 12 and then each of these are x, then hopefully it makes sense that this length here should be 12 minus 2x, and then these here are also going to be the same thing. These are also going to be 12 minus 2x. Okay, so with that, volume is going to be the, let's do base times height, right? So the base is going to be, the base is going to be 12 minus 2x times 12 minus 2x. And then the height, when these sides get folded up, is simply just going to be x. Okay, so there's our volume. So what we want to do here is we want to FOIL this thing out here. All right. Or you can stack it, whatever floats your boat. It seems like more people like FOIL. I like stack, but I like U more than stack, so I will FOIL this thing out. So 12 times 12, 144. 12 times negative 2 is negative 24x. x. Negative 2x times 12 is also negative 24x. And then negative 2x times negative 2x is 4x squared. All right. So let's see if we add these all together. We get 4x squared minus 48x. So we're going to add the two negative 24s together, plus 144, right? And then this is all, let's see, this is volume equals, that's a V, sorry. And then this is all being multiplied by x. So volume equals, multiply all these by x and you get 4x cubed minus 48x squared plus 144x. All right. So what we're going to want to do now is let's take the derivative of this thing here, because again we've got this cubic function here, and we're trying to figure out when we can maximize the volume. Okay, so the derivative is going to be, let's see, 12x squared minus what, 96x plus 144. And again, if we're trying to maximize, we know that the slope of the tangent is going to have to be 0. All right, so now we just want to solve this. Now, if you look at this, we can actually, all these have a factor of 12, which is going to make our life so much easier. So let's just divide everything by 12. And we get 0 equals x squared minus 8x plus 12. Okay? So now we just simply factors of 12 that add up to that add up to 8. So factors of 12 are 1 and 12, 2 and 6, or 3 and 4. So the factors there that add up to 8 are 2 and 6. So we do x and x, 2 and 6. This sign here always goes with the bigger of the two. And then this sign here tells us that these two signs have to be the same. So x has to equal 2 or 6. Okay, now let's just make sure that these make sense here. If you took 2 out of each side, that would leave us with what, 8? 8 by 2, that would make sense. If you take 6 out of each side here, if you take 6 on this side and 6 on this side here, and you started only with 12, you would have 0. So the answer of 6 does not make sense, so x has to equal 2. All right, so that means we simply are going to cut a 2 centimeter by 2 centimeter square out of each corner. To maximize volume. Oops. Okay. Sorry about the crummy handwriting. And that's supposed to be an M. You get the idea. All right. So, there we go. 2 by 2 square out of each corner. Okay. So, it doesn't even actually ask us what the volume is, so we don't have to figure that out. So we'll just leave it. Okay. Of course, you could find it out if you wanted to, but you should now be able to say that I can find the optimal value for a variable in various real life situations. Okay. If you have any questions, please ask.